In this video, we are going to create a chat server, a simple chat server using Rust. Let me explain the architecture with the simple simulation. Our server will keep a DashMap entry for each client with their user ID as the key, and as value is going to be the client information. And our server will create two tasks, two Tokio tasks for each client. One is going to be the reader task, which will read and wait for messages from client. And we will create a channel. We will use multiple producer and single consumer channels as a buffer. You can say it is like a mailbox. Okay. So whenever allies will try to send the message, reader will receive the message. We will check the dash map entry if the receiver is present or not. If receiver is present, we will push that message to their mailbox, and from their mailbox the writer task will take the message and push it to the client. If I click the send message from the other client side, receiver will receive it. We will check the dash map, push it to the others mailbox. Now let's create a new project and build this thing. So let's create a new project. So I'll say cargo new NTS. So it will create a new application of Rust. Okay, it's done. So I'll say code NTS. Perfect. So new window is opened. First, we will make sure if a Rust analyzer extension is enabled or not. So I'll search for Rust and enable it for the workspace. Now we need to install some dependencies. And I'll say cargo add Tokio util with codec. Another thing we need is cargo add Tokio with full feature. Another packages are cargo add DashMap and futures. If you want to check what is DashMap is just concurrent hash map for Rust. Now we have all the dependencies and we can start with the coding. So first I would like to define some types like client TX. It is going to be our multi producer and single consumer channel, and it is a type of sender. We would also need a struct with the client information. For now we will just store the sender part of the channel because that is what we required right now. We can also store user ID, something like this, string, right? But it is not required right now, so just keep it simple. Another type we required is peer map. So it is arc of dash map, string as a key and client as a value. For now we will just use these three types. We are using asynchronous environment, and for that we need to attach the Tokio main macro and make the main function asynchronous with async keyword. Now, in order to start the TCP server, we need port and the address. So I'll just get the port from the environment variable. So I'll use std, env, and var. First, I will try to get the port from the environment variable, and if it is not present, then we will use the default one. Okay, the string is required, so toString. Perfect. Now let's prepare the address. So I will use the format macro. I'll say 0.0.0 and the port. Perfect. Now let's create the listener. For that we will use TCP listener coming from Tokio, and we will bind the address. I'll say await, and it is returning the result. And if there is any error, I will just pass on the error with this question mark operator. This operator can only be used in async block that returns result. Okay, so our main function is right now returning nothing. So I'll make this stdio and result. Okay, fine. Now in order to accept multiple connections, I will run an infinite loop, and I will say let stream listener dot accept. So we bind our TCP server with the address. We run the infinite loop to accept multiple clients. We will accept the client connection and spawn a new Tokio task. We will say async and call the handle client function. Okay, let me define this function. Wait. Okay, now we need to create a global DashMap data structure where we can store the entry of peers. So peers, the type is going to be peer map. I'll say arc new DashMap and new map. Perfect. Now our server is binded. So I would like to print a message here. So our global entry is ready. Now I will pass this stream and this peers entry to this task in the handle client function. But we cannot directly send it. We have to create a reference clone, peers.clone, and we will pass the stream and the peers clone in the handle client function. And obviously we have to receive these arguments in this function. So stream is going to be TCP streams coming from Tokio net, and peers is peer map. This handle client function has to be asynchronous, and in order to execute async functions, we need to use .await. Otherwise, this function will never execute. Now let's test if this server is running or not. Let's check if we are getting this message or not. We got some warnings, but at the end, server is running on the port 8080. Server is working fine. Now let's handle the client. For handling the client, I would like to mention some steps. In the first step, we will create lines frame using Tokio util. In step 2, handshake. Since we have the name, now we can create channel for channel for the user, for the client we can say. Channel, we can say the mailbox, the queue, etc. In Rust it is called channels. Okay. In step 4, we will register the user in DashMap. Next, we will create task A. It is going to be our writer task. A writer task will, what it will do, read the message from channel and forward to client. Another task we need is reader task. Wait for client's message and forward the message to the receiver's channel. Okay, so these are the things we need to do. First, let's do this. I'll say lines, and I'm going to use framed, which is coming from Tokio util codec framed. Why I am using it? It is helping us read the socket line by line. We don't have to read the bytes. It will provide us the line directly. So I will pass the stream, the TCP stream I'm getting from the uh, listener accept, and here we need to use lines codec coming from codec line. Okay, I'll create the new instance and pass it. Perfect. Now in the handshake, I'll say let's send the message. Message is going to be enter your name. Simple, and I'll await and say unwrap. Okay, we need line mutable. So I'll mark the line as a mutable variable. So we send this message. Now we have to wait for the reply. So I'll say from the lines, get the next line. I'll wait, and let's check what we are getting from this. So it is options. So I'll say, okay, fine. Let this S, and I will match on this option. since it is option, so we will use sum and return something, and if there is anything else, we will just return from there. Perfect. So S is further result of string, so I'm not interested in the lines codec error right now, so I'll just process the line here. No problem. So this is the user's response, and I believe this is going to be the user ID. We are assuming that. Now we have the user ID. Now the third step is to create the channel. Let's create it. So one instance is going to be the sender, another is receiver. So we are using multi producer, single consumer channel, which is coming from Tokio, and the buffer size is going to be the 100, and the channel will deal with strings. Perfect. Now we will register the user in our DashMap, our routing table. So here is our peers, the global routing table. I'll use user ID dot clone as the key. Value is going to be the client and the TX. Perfect. Now let's create the writer task. So in this channel, if any message we receive, we would like to forward the message to this client. So I will spawn new Tokyo task. I'll say writer task and Tokyo spawn async wait async move and this thing. Perfect. So I'll say while let some message is coming from rx dot receive dot await, then do what if there is any message we would like to push this message to the client. Now we would like to split our lines stream so that we can independently use writer and reader part. So sync and mutable stream. Okay, with the help of sync we would be able to send the message to this client, and from stream we can receive messages from the client. Right now we have to send the message, so I'll say sync dot send this message and await. Let's check what we are getting as a result. So if it is success, then there is no result, but there is error, so we can check something like this. If let there is any error while doing this operation, then we can simply say break. So we will break out of this while loop. Why? Because client is probably disconnected, right? So if client is disconnected, we will just break out of the loop. Simple. And this thread will be free. Okay, so writer task is done. Now our task B. This is running in completely different task, and it is independent from this function, and it won't block this area. And we will come to this task, the reader task. So I'll say while let I'm getting some result while performing this operation. So we would like to listen for the incoming request, incoming messages from the client. So I'll say stream, get the next line, wait for it, and if there is any result, since you can see the result is type of result, we can either get the string or the line codec error. So I will match and I'll say if everything is okay, we get the line and we will process it. And if something went wrong, then we will say break. So this is the format we are getting the message from the client. We are assuming this. In future, we will improve it. But for now, for simplicity, let's keep it. So in order to get the user ID and the message, we need to split the string from the middle, from the semicolon. So I will say split this line once with the delimiter colon. Let's check what we are getting. Obviously, but let's check it. It is option with two strings. So I will say if let there are two strings, one is going to be the destination ID and one is our message. If there is some destination ID and message, I would like to check for this destination ID if this exists in our DashMap or not. So let's check it. So if let some receiver from the peers will get, not like this, we will get for the destination ID. If there is some receiver, we would like to send the message receiver.tx.send and format. Let's say if we didn't found any receiver with that user ID, we will simply say not found message to the current user. Perfect. If receiver exists, we will send this message. If does not exist, we will say this user is not connected. For now, this is the very simple forwarding protocol. We will upgrade it in next video. And if there is no line, then we will break the loop. It means client disconnected. And when this loop will break, we would like to terminate the writer task as well. So I will say writer task dot abort this writer task. Okay. And we also would like to remove the entry from the peers. And let's print a single message that this is disconnected. User ID. Perfect. Now let's test this server if it is working fine or not. So one terminal here, and I would like to get the split terminal here. Perfect. So I'll say cargo run. By default, it will run on port 8080. Fine, it is running. In order to connect to our TCP server, I will use our existing TCP client, which is netcat. So I will say nc localhost port 8080. So it is asking for my name. I will say alias. I will do the same in the another terminal, and I'll say Bob. Let's say Alice want to send message to Bob. So the protocol says the user ID and the message, and I'll say hi Bob. Okay, so this hi Bob message is being delivered to the Bob's terminal. I can do the same from this client. Okay, so this message is being forwarded to the right client. Okay, we can do one more thing. Let's open one more terminal, netcat connect, and I'll say Vivek. Okay, now let's talk with Bob. Now let's check if Bob received the message or not. Okay, so Bob received the message but Alice didn't. It means the message is being forwarded to the right client, which is perfectly fine. Let's say Alice want to message Vivek. Hey, this is Alice. So Bob is not getting this message, but probably I get this message. So server is working perfectly fine. And as I close the program, server is saying Vivek is disconnected. Perfect. And if I try to send the message to the person who is not present in the server, let's say Vivek is already disconnected and Bob is trying to send the message to the Vivek. Now let's see what happens. So server is saying Vivek is not connected. Okay, so this logic is also working perfectly fine. In this video, we created a simple chat server which is forwarding a plain text messages. In next video, we will improve this system to use our own custom protocols. And this time we used a TCP client to test our server. In future videos, we will create our own custom TCP client to accept the connections and encrypt the messages as well. So stay tuned and I'll see you in the next video.